Welcome to Solar Radiation Fundamentals for Solar Photovoltaic Systems. This section covers solar terminology, atmospheric effects, solar power and solar energy, and the measurement of solar radiation. Solar energy is the fuel that creates and sustains life on Earth. The nature and characteristics of the solar radiation resource are of fundamental importance in understanding how a solar PV system are designed and perform. In this section, we will cover terminology associated with the solar radiation, including solar irradiance and peak sun hours, and we will identify the instruments used for measuring solar radiation. In sections 2 and 3, we will complete understanding the effects of the Earth's movement and atmospheric conditions on the solar energy received on the Earth's surface, and locating the sun's position using sun path diagrams, and accessing solar data radiation resources and quantifying the effects of the collector orientation on the amount of solar energy received. The sun is 93 million miles or 150 million kilometers from Earth. Light travels 8.3 minutes to travel the distance. The sun is 109 times bigger than the Earth and has a mass 33,000 times that of Earth. The Earth is 3 times more dense than the sun. The sun is a giant object and is expected to shine for another 5 billion years. The sun produces immense quantities of electromagnetic radiation. The tiny fraction reaching the Earth's surface amounts to approximately 170 million gigawatts, many thousand times greater than the electrical power used on Earth. The United States uses just over 1,000 gigawatts of electrical power. Solar radiation is electromagnetic radiation ranging from about 0.25 to 4.5 micrometers in wavelength, including the near ultraviolet, the visible light, and the near infrared portion of the spectrum. Solar irradiance or solar power. Solar irradiance is sun's radiant power incident on a surface of unit area commonly expressed in units of kilowatts per meter squared or watts per meter squared. The solar constant is the value of solar irradiance outside the Earth's atmosphere on a surface facing the sun's rays, which is about 1,366 watts per meter squared. Due to atmospheric effects, typical peak values of terrestrial solar irradiance are in the order of 1,000 watts per meter squared on a surface at sea level facing the sun's rays, under clear conditions around solar noon. Consequently, 1,000 watts per meter squared is used as a solar irradiance reference condition for rating the peak output for PV modules and arrays. In the northern hemisphere, on a south-facing fixed, non-tracking surface on a clear day, the incident solar radiance varies over the day in a bell-shaped curve, peaking at solar noon. This is same true for north-facing surfaces in the southern hemisphere. Solar irradiation or solar energy. Solar irradiation is the sun's radiant energy incident on a surface of unit area commonly expressed in units of kilowatts hours per meter squared for monthly averages, and it gives on a given surface orientation. Insolation is also a term used to represent solar irradiation. Solar irradiation or solar energy is equal to solar irradiance or solar power integrated over time. Peak sun hours or PSH is the average daily amount of solar energy received on a surface. A peak sun hour is equivalent to the number of hours that the solar irradiance would be at a peak level of 1 kilowatt per meter squared. Also the equivalent of number of hours per day that a PV array will operate at peak output levels at rated temperature. Similar to electrical power and energy, solar power and solar energy are related by time. The amount of solar energy received on a surface over a period of time is equal to the average solar power over the period multiplied by time. Graphically, solar irradiation or solar energy is the area under the solar irradiance power curve. Peak sun hours, or PSH, represents the average daily amount of solar energy received on a surface, equivalent to the number of hours that the solar irradiance would be at a peak level of 1 kilowatt per meter squared, or 1000 watts per meter squared. It is also the equivalent number of hours per day that a PV array will operate at its peak rated output level at rated temperature. Peak sun hours equal the number of equivalent hours times at 1 kilowatt per meter squared of irradiance. Let's look at some solar power and energy examples. The solar power incident on a surface averages 400 watts per meter squared for 12 hours. How much solar energy is accumulated? The solar power incident on a surface averages 400 watts for 12 hours. How much solar energy is accumulated? 400 watts per meter squared times 12 hours equals 4,800 watts per meter squared equals 4.8 kilowatt hours per meter squared equals 4.8 peak sun hours. Solar power defines the instantaneous output of a PV system. Question 2. The amount of solar energy collected on a surface over 8 hours is 4 kilowatt hours per meter squared. What is the average solar power over the period? This is the reverse of number 1. Four kilowatt hours per meter squared divided by 8 hours equals 0.5 kilowatts per meter squared, or 500 watts per meter squared. The amount of solar energy accumulated defines the equivalent number of hours that a PV will operate at its peak output level. Number 3. A PV system produces 6 kilowatts AC alternating current output at peak sun and average operating temperature. How much energy is produced from the system per day? If the solar energy received on the array averages 4.5 peak sun hours per day. A peak sun hour equals 1000 watts per meter squared per hour. 6 kilowatts times 4.5 hours per day equals 27 kilowatt hours per day. Now let's talk about the atmospheric effects. Approximately 30% of extraterrestrial solar power is absorbed or reflected by the Earth's atmosphere before reaching the surface. Effects vary significantly with altitude, latitude, time of day and year, atmospheric constituents, weather patterns, and the wavelength of solar radiation. Direct beam normal radiation is the component of total global solar radiation incident on a surface normal to the sun's rays that comes in parallel directly from the sun's rays. Diffuse radiation is the component of total global solar radiation incident on a surface that is scattered and reflected, and may also include ground reflected radiation. Total global solar radiation is the component and is comprised of the direct, diffuse, and reflected radiation. The value at the edge of the atmosphere is 1366 watts per meter squared, and the value constant at Earth is 1000 watts per meter squared. Air mass. Air mass is the relative path length of direct solar radiation through the atmosphere. Air mass affects the amount and spectral content of the solar radiation reaching the Earth's surface and varies with sun position and altitude or barometric pressure. An air mass of 1.5 defines the spectral radiance characteristics for testing and rating the electrical performance of PV modules and cells. An air mass of 1 is the standard amount of 1 atmosphere measured at ground level. Solar radiation measurements. A pyranometer measures total global solar irradiance or solar power. Measurements of time are integrated or averaged to calculate the total solar irradiation or solar energy received. Irradiance measurements are used in the field to translate the actual output of a PV system or array to a reference condition to verify the solar system's performance. Small, inexpensive meters, usually calibrated PV cells or sensors, are available from around $150 and up. A small PV module with calibrated short-circuit current can also be used to approximate solar radiation levels. A precision spectral pyranometer. This pyranometer measures a broad band of global solar radiation, direct and diffuse, with a thermopile. It is used for precision laboratory measurements and weather stations. Dual glass domes improve low incidence angle and thermal accuracy. This is an expensive item. A normal incidence pyroheliometer. A pyroheliometer measures direct beam radiation. A pyroheliometer shown here measures the direct normal component of total global solar radiation. The instrument must always track the sun via a sensor, which is located at the back of a long tube and has a field of view of 5.7 degrees, the width of the solar disk. This is an expensive item. Handheld solar items like the Daystar solar meter use a small PV cell to measure solar irradiance. Careful alignment with the plane of array is required for accurate measurements. This is a low-cost item and is good for basic field measurements. That is the end of part 1 of 3. Complete the quiz for this section and then continue to watch part 2 of Solar Radiation Fundamentals.